Hello students, welcome you all to the video lecture on signals and system. Today we are going to see a problem on difference equation. So for a causal LTI system, the input x of n and output y of n are related through the difference equation y of n minus 1 by 6 y of n minus 1 minus 1 by 6 y of n minus 2, which is equal to x of n. So we have to determine the frequency response h of e power j omega and impulse response h of n of the given system. So here it is a discrete system. So for the discrete system we can apply either Z transform or discrete Fourier transform. That is your DTFT, discrete time Fourier transform. Either Z transform we can apply or DTFT we can apply. So to find out the frequency response, definitely we need to apply the DTFT. So again, when comparing to your Z transform and DTFT, for Z transform we use the term Z, and for DTFT we use the term e power j omega. Okay, so instead of using e power j omega, it is very easy for us to use Z transform. That is, we can apply Z transform easily. So first let us use the Z transform itself, and the relationship between the Z transform and DTFT is nothing but wherever you have Z, just replace it by e power j omega. So using that you can easily determine the frequency response, and finally by using your partial fraction methods and all, we can determine the impulse response h of n. Okay. So this is the problem. First let us apply the Z transform on both sides. So while applying the Z transform, we know that Z transform of y of n is y of z, and Z transform of y of n minus 1 is z power minus 1 y of z. Z transform of y of n minus 2 is z power minus 2 y of z. Okay. So whatever you have, minus 1 means just write in the power, z power minus 1 y of z. Similarly, minus 2 means z power minus 2 y of z. If it is just y of n, you can replace it by y of z. Similarly, Z transform of x of n is capital X of z. Okay, so small x will become capital X, small y will become capital Y, and n will become z in the Z transform. So using all these things, let us apply the Z transform for the given equation. So y of n will become y of z minus 1 by 6. Coefficient will remain as it is, constant term remain as it is. Y of n minus 1 means z power minus 1 y of z minus 1 by 6. For this Z transform is z power minus 2 y of z, which is equal to x of z. So here take all your y of z commonly outside. So what happens? Here the coefficient is 1, 1 minus, here it is 1 by 6, minus 1 by 6 z power minus 1, here minus 1 by 6 z power minus 2. Just you are taking y of z commonly outside in all the terms. So right hand side is x of z. So once you have done that, y of z by x of z is nothing but, here the coefficient is what? 1. 1 by 1 minus 1 by 6 z power minus 1 minus 1 by 6 z power minus 2. So here I am taking x of z to the left hand side. So numerator is 1. This term will go to the denominator in the right hand side. So you are writing as this. So once you have done this, all the terms are in inverse z. So convert that into positive power of z terms. So here the higher power of term of z is nothing but z power minus 2. So the opposite power you just multiply in both numerator and denominator. Okay, that is z square we need to multiply. Suppose if we have z power minus 3, we have to multiply numerator and denominator by z cube. So here the higher power term is z power minus 2. So just multiply by z square in both numerator and denominator. So what happens? This becomes z square. This becomes z square into 1 is z square. Z square into z power minus 1 is z. So minus 1 by 6 z minus 1 by 6. Z power minus 2 into z power 2 is nothing but 1. Okay, so both get cancelled. You will get only the constant term here. So now this is the transfer function. So the transfer function or system function, okay, transfer function or system function h of z is nothing but y of z by x of z, which is nothing but z square divided by z square minus 1 by 6z minus 1 by 6. So once you have determined that, you can easily find out the frequency response. So the frequency response is given by, so in the question they have asked to find out the frequency response. Frequency response is given by h of e power j omega. So wherever you have z, just replace it by e power j omega. Okay. So here we have z square. So z square we can write it as e power 2j omega divided by, again denominator I have z square, it is e power 2j omega minus I have 1 by 6 z is e power j omega minus 1 by 6. Okay, so just we can substitute the value of z as e power j omega in the previous expression. Okay, so z equal to e power j omega. So z square is e power 2j omega. Denominator also we have z square, that is e power 2j omega minus 1 by 6. Again I have z, so it becomes e power j omega minus 1 by 6. This is my frequency response. So wherever you have z, just replace it by e power j omega. So once we have done that, we have to find out the impulse response h of n. So we need to find out impulse response h of n. For that, again let me take the previous transfer function expression, that is h of z is y of z divided by x of z, which is nothing but z square divided by z square minus 1 by 6z minus 1 by 6. Okay. So we know that for impulse response, so whenever you have a system, the input signal we have to consider as impulse signal. That is, input signal we have to consider it as del of n. So when you are applying the impulse signal to the system, definitely the output which we will be getting is nothing but impulse response, which is denoted by h of n. Okay. So what do you mean by that? In order to find out the impulse response, I have to consider the input as impulse signal. So therefore x of n, we need to consider it as del of n, which implies wherever you have x of z, we have to find the z transform of x of n, that is nothing but z transform of del of n. Okay, what is z transform of del of n? It is 1. So therefore wherever we have x of z, we have to just replace it as 1. Okay, so this is what we have to apply in the given expression. So we have determined that x of z is 1. So by simple, you can memorize that for impulse response x of z is 1. Okay, why? Because x of n is del of n, so x of z is 1. Okay, suppose if they are step response, x of n is u of n, so x of z is z by z minus 1. Okay, so in that way you can simply memorize. Okay, but this is the thing what we have done behind that. So wherever we have x of z, just replace it as 1. So what happens? This whole equation again it becomes h of z is nothing but y of z. Why? Because this term becomes 1, z square divided by z square minus 1 by z minus 1 by 6. Okay. So in order to apply inverse z transform, we need to take one z to the left hand side. Okay, anyway y of z is nothing but x of z, we can leave y of z, just we can take this expression as h of z. Okay, and then we need to apply the partial fraction, and we need to find out the inverse z transform of h of z, which is nothing but h of n. So x of z, h of z is nothing but z square divided by z square minus 1 by 6z minus 1 by 6. Okay, so one z we have to take to the left hand side, that is we need to determine h of z by z. So when we take one z to the left hand side, it becomes z by z square minus 1 by 6z minus 1 by 6. Let me factorize this term. Okay, so minus 1 by 6. So when we multiply, we should get minus 1 by 6. When we add, we should get minus 1 by 6 again. Okay, so it is in 1 by 3 minus 1 by 2. So how we are getting this means, you can use your calculator. Okay, so when you multiply, what happens? It is minus 1 by 6, and when you add, okay, cross multiply, 2 minus 3 divided by 6. Why? Because the LCM of 3 and 2 is 6. Okay, so minus 1 by 6. Okay, so this is correct. So I have to solve this equation in either using the calculator, or in the online I'll show how to calculate. You can use that also. Okay, so you can use this website. Give x square. Instead of z, I am using x square. Okay, so just give your polynomial minus 1 by 6. Okay, x, and then again minus 1 by 6. C value is minus 1 by 6. Okay, which is equal to 0. Okay, just give equal to 0, so that you will find out the roots. Okay, roots of the given equation you can find out. Yeah, what are the roots? It is 1 by 2 minus 1 by 3. Okay, so roots are 1 by 2 and minus 1 by 3. 1 by 2 minus 1 by 3. But while writing the expression, you have to change your sign and write. Okay, so this is what you will obtain in the calculator also. So what happens? I can write it as z minus 1 by 2. Change the sign and write the expression z plus 1 by 3. Okay, so this is what I have. Instead of using the calculator, you can directly find out the roots also like this, or you can use the online calculator as what I have used, or you can use in the calculator. So in the calculator, what you have to do, press mode until you get the equation, and then press right arrow, use degree. In the degree you should give 2. Okay, so once you have given 2, you just give the coefficient of z square. Coefficient of z square is 1. So give a value is 1. Coefficient of z is b. Give b value as minus 1 by 6. Give c value as constant value, that is minus 1 by 6, and press equal to in the calculator. So you will get to 2 values. One value it is 1 by 2, one value it is minus 1 by 3. So whatever you are getting in the calculator, you have to change the sign and you have to write. Okay, so don't write the value as it is, z plus 1 by 2, z minus 1 by 3 means here itself the problem is wrong. So just change the sign of the roots whatever you are getting in the calculator and write the equation. So once you have done that, now this is the value. What is this? H of z by z, which is equal to z by z minus 1 by 2, z plus 1 by 3. So apply the partial fraction, a by z minus 1 by 2 plus b by z plus 1 by 3. Okay, so what is your numerator? Numerator is z, right in the left hand side. Cross multiply and write, or just compare the value in the denominator. Here already z minus 1 by 2 is there. Okay, what is not there? Z plus 1 by 3. That value you multiply with the a. So z plus 1 by 3 plus b into, compare the denominator with this. Already z plus 1 by 3 is there, which is not there, z minus 1 by 2. Multiply with b. Okay, so what are all the values I have to substitute? I have to substitute z equal to minus 1 by 3. Here it is plus 1 by 3, so I have to substitute z equal to minus 1 by 3. Okay, and then here z minus 1 by 2, so opposite sign. So I have to substitute z equal to 1 by 2. Okay, so just substitute z equal to minus 1 by 3. So minus 1 by 3 equal to, anyway when you substitute minus 1 by 3, this term get cancelled. Only b value you will get minus 1 by 3 minus 1 by 2. Okay, so minus 1 by 3 equal to b. LCM is 6, cross multiply, minus 2 minus 3. Okay, so minus 1 by 3 equal to b into minus 5 by 6. Anyway minus minus get cancelled, 3 2s are 6. Okay, so I have b equal to 2 by 5. Okay, so here it is 1 only, here it is 5 by 2, so b equal to 2 by 5. So once you have done that, find out the value of a. So left hand side it is z, z equal to 1 by 2. Okay, so a into, wherever you have z, replace it by 1 by 2. 1 by 2 plus 1 by 3. So anyway this value get cancelled. So 1 by 2 equal to a into, again LCM is 6, cross multiply 3 plus 2. Okay, so this and this you can get cancelled. So 2 3s are 6. Okay, so left hand side you have only 1. Here it is 5 by 3. Okay, so a value is nothing but cross multiply, it is 3 by 5. Okay, so b value is 2 by 5, a value is 3 by 5. So once you have done that, in this expression you have to substitute. Okay, so a value is 3 by 5, b value is 2 by 5. So I can write h of z by z as a value is 3 by 5. Okay, 3 by 5 divided by z minus 1 by 2. B value is 2 by 5. 2 by 5 divided by denominator is z plus 1 by 3. Okay, so this is my h of z by z. So now take z to the right hand side. So h of z is 3 by 5 z by z minus 1 by 2 plus 2 by 5 z by z plus 1 by 3. Take this z to the right hand side. So once you have done that, you can apply inverse z transform. So h of z will become h of n. Here coefficient is 3 by 5, that is constant term is 3 by 5. What is z inverse of z by z minus 1 by 2? General form z inverse of z by z minus a is a power n u of n. So here it is 1 by 2 the whole power n u of n. Similarly, z inverse of z by z plus 1 by 3 is minus 1 by 3 the whole power n u of n. So using that I can write it as 1 by 2 the whole power n u of n plus 2 by 5 is constant minus 1 by 3 the whole power n u of n. Okay, so this is the final impulse response, that is your h of n is determined. Okay, thank you, thanks for watching.